What's 2 plus 2? Error.
Welcome to all our Floridian people that Floridian followers that are not getting snow right now. We have this thing, white stuff in Minnesota called snow, and we have one person who's gone, and I hope she's not in a ditch.
I think she
Is she what?
because the subs and boys, she lives past the one girl going on vacation is gonna come, and now Renee's gone classes.
Who else is gone?
We'll figure it out.
Okay, so are we going to give?
Hi, Renee.
Okay, so Renee, we're here just to make you sure that this is taped in front of a live audience. Okay.
The laugh tracks you hear
I'm just,
are real.
and I'm just, and I'm just saying that some people here are more alive than others. Speaking of alive, Matt. What would you have as an answer for this? This limit. We're going to review limits.
2.
Very good. Ray, what about this one?
4.
How'd you get 4? Okay, this is pre-L'Hopital's rule, but you are correct.
Then you would be able to do it.
Yes, you would. But that is a nice response also.
2 minus 2. 0 over 0.
Can you factor? I believe that's a difference of squares, and I should get some conjugates. Yeah, it's those dangerous conjugates. I know. I'm
X plus 2, X minus 2.
2 of them are my brothers. All right, x plus 2, x minus 2. All right, so those simplify. What do they indicate about that function?
Has a either a whole or has a
Yeah, it's one of them.
Is it a whole?
It's a whole. Very good. The whole is at what point?
X equals 2.
And so y would be
4.
4. So if I would graph this, 2, 4 would be somewhere like this. That's what the graph would look like. Okay, so the limit is what, 4?
Yep.
Okay. Jack Grabinski, what would you do here? Multiply by the conjugate. What is the conjugate?
Square root of x plus 2 plus 2.
And I will do the bottom. Is that okay? What do you get on top?
X plus 2. Yeah. X plus 2.
For that product?
Yeah.
Okay. Well, these are conjugates, correct? So there's no middle, right?
Minus 4.
Minus 4. And that x plus 2 minus 4 is the same as
X minus 2.
x minus 2. Are we happy to see x minus 2?
Yeah.
Okay. Why? What happens at x minus 2? They simplify? Yeah, some people are into death. Okay. And so what is my limit here? Yeah, you get 2 plus 2 is 4, square root of 4 is 2, 2 plus 2 is 1/4. So 1/4. Awesome. Very good. Okay. Let Renee see that. Oh, infinity. See, I usually get this wrong because I start factoring right away. But Jack Lukanen, I don't have to factor because I have nothing to substitute, right? I'm going to substitute 100 in there, 1,000, or a billion, or a Google. or a googolplex probably, right? What will I get as an answer?
1/3.
1/3. And how do you know it's 1/3?
Because the power of the numerator and denominator are the same, so you take the leading coefficient of each one.
So these degrees are the same?
Yeah.
Okay. Otherwise, there's several powers up there to
Well,
look at.
yeah, that's what I meant.
Okay.
I said 0.
All right, so do you remember us talking about indeterminate forms?
Yes.
Okay. These are indeterminate forms. These are the groups we looked at last time. We talked about 0 over 0. I got yelled at because I said the word, I was describing something. I said 0, 0 at the AB conference. Did I tell you that? And they said that's not allowed because you can't have division by 0. So obviously you can have division by infinity. And so these are what the forms are, and I got this from a textbook. But I'll show you how they want you to have your justifications, which are somewhat different than last year, okay? So what they would rather have is, like in this case, the one that Raymond was working, this is a function, correct? I could call that function f, and I could call this function g. I can say the limit as g approaches 2 is 0, and the limit as f approaches 2 is 0. Well, does that mean I have a 0 in the numerator and the 0 in the denominator? Yeah, that would be the case. But I have to separate them when I have a justification. Does everybody understand that? I can't say it's in an indeterminate form. I have to say what the limits of each of those functions are individually. So let's take a look at this. L'Hopital's rule, I rewrote it from the notes from last year. I said L'Hopital's rule only applies to taking the limit of the first group, and if you're asked to take the limit of the second group, you have to rewrite this form so it looks like the first group. L'Hopital's rule states that if the limit of a function as approaches c is 0, and the limit of the function g as x approaches c is 0, or approaches either positive or negative infinity, where c represents, now look at this, is a little bit different, any real number or any positive or negative infinity. So c is going to represent something more than a constant. You can take the derivatives of f and g separately and then examine that limit. Now, if that limit, again, the derivative is equal to 0 and both derivatives equal 0, you can keep taking the derivative, okay, until one is not, okay? So here's an example. So if I would take the limit, and this is how the first thing I need to express. What is the limit of that Tristan? What?
0.
Perfect. Because you got 1 minus 1, right? And then what is the limit of this? 0. So that means I can now apply L'Hopital's rule, because I demonstrated those two things. All right? So I'm now going to take the limit as x approaches 0. And what is the derivative of e to the x minus 1, which was quite frightening to my AB students just last period? E to the x. And now it's not as frightening anymore, is it? We kind of like e to the x, don't we? Like it's a lot less work. And what's the derivative of the bottom?
1.
1. So what's my derivative now?
E to the x. What's the derivative?
Excuse me, what's my limit now?
Okay.
I'm sorry. I misspoke. 1. Because e to the 0 is 1, and 1 divided by 1 is not a problem. Next page. This one is one of my favorite. I don't know if you remember me doing the squeeze rule. Okay, I had two people, they're being squeezed by somebody else or something like that. Were you involved in that?
Yeah, I was a squeezer.
Were you were a squeezer or a squeezee?
Squeezer.
Squeezer. Who was the squeezee?
It was cool.
Cole. Cole? Oh, yeah, yeah, because I did a height thing, didn't I?
Yeah.
Yeah, I was trying to be funny.
That was good.
It was a little.
Yeah, it was a little funny. Very good. All right, so how would I start this out, Maggie?
Just like what side of the side of X?
Take the limit of the sine of x,
Yeah.
and I would get
0.
0, and then I got the limit. And Tristan already did this one for us, so we're going to do that. So I now can apply and take the limit as x approaches 0 of what, Maggie?
Cosine of X all over 1.
And I get
1.
1. Beautiful. All right, Nate, start us off. The limit as x approaches 0.
E to the x minus 1 is 0.
You're tell me this, right?
That's 0.
Okay. And so now I'm going to apply the rule. And I'm going to get what?
The limit of e to the x over 3 plus 2x as x approaches 0.
Okay, and we get
1/5 or no, 1/3.
1/3. Very good. Jake, did you want to borrow a calculator, you said?
No.
Oh,
I
okay.
think he said he wanted to.
Yeah.
No problem.
Okay, Jake,
Yep.
how do you think we should start?
Prove that the top and bottom will equal to 0.
I don't think so.
Oh, it's infinity.
Yeah. What is this? Where is this headed?
That's headed to infinity. The bottom's headed to infinity. So it is 1.
Okay, just let me catch up here. Like that. Some ugly infinity symbols. So that means I can approach this, the limit as x approaches infinity of what?
E to the x over 1.
E to the x over 1. And what's the answer? Infinity. Do I have to check each one? Or am I done? Is my answer infinity?
You're good.
You're good. Why? You're right, it's infinity, and I'm done. To apply the rule again, what would have to be true?
All the bottom would be equal to 0, so you'd have to be able to take the derivative of the bottom.
Well, if I took the limit of that, I need to show they're both going to infinity again, correct?
Yeah.
So if I take the limit of that, I'm going to infinity, correct?
Yeah.
But if I take the limit of that, I'm getting 1. Okay? So I'm done. All right. Jack Lukanen, have I asked you anything?
Yes.
Oh, I have.
I don't remember it.
I bet he remembers.
Yeah, I do, so we should still check.
I'm going to ask Austin. Okay? Austin, how am I starting?
We're going to start by setting the top, so limit as x approaches infinity of ln of x, and then that should be infinity.
Okay? It's growing, but it's growing very slow. Would you agree?
Yeah. Same thing at the bottom, limit as x approaches infinity of x squared equals infinity.
Okay, so this is going to be the limit as x approaches infinity of what?
1 over 2x squared.
Oh, wow, how did you do that so fast? Can you slow down for me?
Yeah.
What would I have
So
gotten on
it'd be
top?
1 over x on top and then 2x on the bottom.
Oh, and you said that's the same as the limit as x goes to infinity of 1 over 2x squared. I got it.
Now
All
equals
right.
0.
And that equals 0. And that is a number, and so that's where we're headed, right? What are we looking at?
I was looking at e pi I plus 1.
Oh, yeah. Why is that up there? Where is that?
It's by your chair. That's what I was looking at.
Oh, okay. We get to prove that. Probably when people are in Costa Rica. Yes.
I'm
You're in Costa Rica?
We didn't use
we do that day. The one and only one moment. Okay? Because there's nothing that stops me from the greatest moment of my teaching career is teaching that. Okay? I actually sang Hallelujah, which people said was more of a scream of Hallelujah. Did you hear me do that?
Yeah, Haley Marie like put it on something.
Was it quite frightening?
Yeah, I was like, what is going on? I was like, you did. I was like, oh my god.
Alrighty. Cooper, how do I start?
Would you in this case want them to be negative infinity?
I do have negative infinity.
I know, but you want to prove that they are equal to that?
Well, no.
Or
Any type of infinity is actually A-OK if you look at
any type?
the forms, yeah.
Well, the limit as x approaches negative infinity of x squared would be negative infinity.
I think that would be
Or would
positive
infinity.
infinity.
Yeah, just thinking.
Okay. And the limit as x approaches negative infinity, this is the same, well, e to the negative x.
That should be infinity as well.
I know, is it? People are saying yes. Isn't this the same as this? Isn't it, or am I wrong? But this exponent's getting negative, right? Oh yeah, the negative of the negative makes it positive. Oh yeah. Huh, you learn something every day. Wow. Okay, so now what do who's doing this? Cooper. So Cooper, I can give L'Hopital a call and keep going.
That'd be the limit as x approaches negative infinity of 2x over, would that be negative e to the x?
E to the negative x.
Negative e to the negative x.
Yeah, that's good. So what does that give me here? Oh, I gotta do this. Otherwise the AP gods get a little testy. Right, that's not the new numerator now, right?
Yeah.
What do you get?
Wait, why do you have to do it there and not in?
So we get infinity and infinity again.
I gotta show that's infinity again, or negative infinity. I gotta show what it is.
You want to have infinity on top yet? Why didn't we do that for anything?
Yeah, because it stopped after the first time.
Okay.
This is a special one because we got to keep going. We have to reapply. You know how you get sunscreen? Let's say you have a tendency to get skin cancer, okay? And you're told every 15 minutes, apply the SP 1022. Huh?
It's too much sunscreen in my skin.
I would. Okay. As long as you don't want to be butchered every day. Alrighty. So, Austin, what's this? Oh, not Austin. Cooper. What is this?
Also negative infinity.
Negative infinity. So now I got the limit as x goes to negative infinity of negative e to the negative x, correct? Is that also negative infinity? Yes. So that means now we can reapply. If I have another dog, I might call it L'Hopital. So what is the derivative of 2x? What is the derivative of negative e to the negative x?
Just be e to the negative x.
So what is that?
Does that go to 0?
Well, let's take a look. Let's put some numbers in there. Okay, you ready? A negative 1. I'd get 2 over e, correct? A negative 2. I'd get 2 over e squared. A negative 3. I'd get 2 over e cubed. So 2 is always staying the same. The bottom is always getting bigger. Wouldn't you agree? So I'd go to 0.
Okay.
Did he answer your question or did he ask you a question?
He answered mine.
And were you satisfied with his response?
Yeah.
Are you sure?
Well, he just like flipped the e to the top, and then you would just plug in a negative infinity, so like
Yeah.
it'd still be 0.
Yeah,
Yeah.
that would work. Yeah.
Yep.
Yep. Sometimes different perspectives are helpful. Alrighty. Nevaeh.
Yeah.
Oh, we don't have it in the proper form, right? So I'm going to write it. Well, you're going to help me write it in the proper form. First of all, there's an error. Can you see the error?
Domain.
Syntax error? What's a syntax error?
Well, it might
It's
calculate.
what she calculates, doesn't want to calculate.
I think this should be positive.
I think you're right.
You know why? Why am I right?
You probably should have a negative square root.
Yeah,
You wanna use
especially,
I.
yeah, since we're not using I, except for the one day, Jack.
So you just remember to do that? Okay.
You're not going to be here?
I know.
You're not going to be here on my special day?
He's gone.
You're going to ruin it for me?
He's
What?
gone.
You're going to be in the sun?
He'll be at Costa Rica.
Are you going to Costa Rica?
He has vacation.
I'm confused now.
We all are.
Finally.
Good job, Matt.
Okay, do you understand why that has to be positive?
Yeah.
Okay. So tell me what to write.
Square root of x over e to the x.
Okay, so the limit as x goes to positive infinity of the square root of x. Where is that going?
0.
Well, let's take a look. Okay, I put 1 in there. I get
Getting
1.
smaller,
Well, I
it's
don't
getting
know.
bigger very slowly. So
Yes, it's
infinity.
getting bigger very slowly. That's a great way to say that. It does get to 100, but I got to put 10,000 in there, right?
So it's going to infinity.
Yeah, it's still going to infinity. It's just going to take a while to get there. It's kind of like between my driving and my mother's driving. Okay? I could get to Rochester in 15 minutes. For her, 50. The limit as x goes to positive infinity of e to the x.
Also infinity.
Yeah, that's going there pretty fast, right? Which is kind of an indicator what's going to happen, right? Extremely fast. Oh, I don't know why I wrote negative. Extremely fast, pretty slow. That's what we had with the natural log, correct? The natural log is pretty slow. So, we can apply L'Hopital's. And what does it become?
I'm trying to think of the best way to like formulate it. The square root of x will be 1/2
You're doing the same thing I do.
x
So-
to the negative 1/2.
right.
So it'll be on the bottom. So
Okay, x, you want me to write the square root of x like that?
Uh-huh.
Okay.
So it'll be 1 over 2 square root of x.
Yeah,
e
because
to the x.
there's your 1/2, right?
Yeah.
Beautiful. All right, so what do you get with that baby? Getting bigger slowly, always staying the same.
It's getting bigger still. So
But it's 1 over that, right?
So it would be going to 0.
Positive 0?
Yeah, it's happy. It's positive.
Fun fact, when you drive
What did you agree?
You know what, Matthew, I'd have to agree with you, because when I drive by the bank in the morning, some days it says -0 for the temperature, and some days it says +0. And you know what? There's my +0.
And you
I've always
and
wondered
you
why.
know those bank thermometers. They're right on with the real temperature all the time, right? Oh my gosh. Actually, when I took programming when I was in college because it was the up and coming thing. There was talk on the horizon that people would have computers in their own homes, and that we thought, no way. And that they would be small, and you could carry them in a couple of suitcases, and we'd say, no way. So I thought, I want to be on the cutting edge. I'm going to be a programmer. So I took programming language, and one of the programming languages I took was assembly language, which a subset of that was binary code. So you program, so in every computer, there's a thing called a processor that takes your inputs, which are simply positive and negative inputs, and creates statements out of them or instructions for the computer to do. And so my project was that somebody could input a number and you could figure out, the computer would figure out the square root of that number to 17 digits. 10,000 lines of code, all in binary code. And one thing you find out, because it's in binary code and you have these registers in which the plus and minuses or the ones and zeros go into, you could have positive and negative 0 because there's a different instruction attached to it. So that's a little sideline, and it's a moment that I forgot, but thanks for bringing it back. All right, so what should we do here? Does anybody know what the answer to that is? What? It looks like it's infinity. Why do you think it's infinity? So that's one guess, infinity.
Because 1 over x is 1 over infinity, which is 0, so it's just 1. Which is just 1. Yeah.
So you're changing your mind?
Yeah.
So now you're saying it's 1. Okay. What about you, Cole? What do you think?
Yeah, I was gonna say 1.
Okay. Neither one. So this is what I'm going to do. I'm going to let y equal 1 plus 1 over x to the x power. Now, does anybody have a machine nearby them?
Calculator?
Yeah. What other machine are we talking about?
I don't know, we were just talking about computers.
Yeah. Error.
Syntax error.
Don't toss me. Sure, you say it's fine because it's not broken right now.
Errors that exist.
So let's go to you got syntax error, did you say?
I really hope just any error. That would be like fitting.
What?
It would be fitting that error.
Just,
Never mind.
move on.
Never mind.
You know, I haven't listened to you.
Huh.
I could put 1 in there. 2, 3,
So up here.
4, 5, 6, 7, 8, 9, 3. Somebody changed their answer to 3.
That's me, I put it at 3, it slowed down real quick.
Oh, and this is what she's saying. Its growth slowed down really quick. Okay? Okay, now it's being raised to a power, but she said that the growth is slower, correct? So think about the functions we looked at that has slow growth.
Or is it just going to E?
Maybe it's going to E.
Why? Why?
Don't wait there. Wait, what?
What do you mean?
Why did that happen?
Too many.
Too many. So your register. So what I learned in assembly language is when you input numbers, they go into a register. There's an overflow location in the register. Eventually, even that gets too full because there's only a certain sized memory, and it'll kick out illogical responses once you get overflowed. Okay, which is what I did when I sat there and put in, I don't know, 75 zeros or whatever it was.
If you put in like 1 to the E to the diffuse E.
Yeah, it is.
Yeah, eventually, and like factorial shows you that. So what I'm going to do is we're going to take a look to see if we can figure out this limit. So I'm going to say that this is what we're going to take a look at. And I'm going to take the natural log of y from both sides. Excuse me. Ln of 1 plus 1 over x. Okay, and I'm going to take the limit as x approaches infinity of the ln of y. Which is the same as taking the limit as x approaches infinity of x times the ln of 1 plus 1 over x. Okay, everything okay so far. So now I'm going to take the limit as x approaches infinity, and I'm going to write x as 1 over x times the limit of 1 plus 1 over x. Yeah, I didn't say natural log though. I wrote it but didn't say it. This? Okay.
Do you write it as 1?
Yeah. You have x, okay. That's the same as x over 1, correct? And if I could say that 1 times x over 1 is equal to x, that's the same as 1 divided by the reciprocal. Because when you have fractions and you divide, you can multiply by the reciprocal.
Oh, why did you do that?
Well, I'm going to show you in a second.
Okay.
Okay. It's called manipulation. In calculus, we like to manipulate backwards. So I get the limit as x goes to infinity of the natural log of 1 plus 1 over x over 1 over 1 over x.
It'll just be 1 over x at the bottom, not 1 over x.
Excuse me, thank you. 1 over x. Where is this headed? 0. Do you agree? That function's headed to 0. This function, this is headed to 0, correct? Correct? 1 plus 0 is 1, correct? The natural log of 1 is what? 0. So I can apply L'Hopital's rule. Would you agree? Right? Okay. When I apply L'Hopital's rule, I'm going to get this on the bottom. Are you okay with that? Can you see that okay? Everybody okay with that? Now I want to take the derivative of this. So I have the natural log, and I'll do it right here, the natural log of 1 plus 1 over x is the same as x plus 1 over x, correct? So its derivative, which is the same as this, the natural log of x plus 1 minus the natural log of x. Would you agree with that? Using my log rules? I didn't do anything wrong, did I? So now when I take the derivative of this, I'm going to have 1 over x plus 1. This is minus 1 over x. This is going to be x minus x plus 1 over x times x plus 1. So this is negative 1 over x times x plus 1. Which is what I'm going to put here. Are we okay with that? So I have the limit as x approaches infinity of a negative x squared over a negative x times x plus 1. This fraction divided by this fraction is this fraction times its reciprocal. What's the limit of this? I can read lips. So,
Can you simplify one of the x's?
I did it, all I did is this has a degree of 2, this has a degree of 2. Yeah, and you're right, yeah, you could have, and then you would have had a degree of 1 over the degree of 1. You'd still end up with 1. Yes, yes, you definitely could, okay? So that means this is equal to 1, correct? So that means the natural log of y, its limit, is equal to 1. That means y has to equal to what? E to the first. So the limit of this has to be e. Yes?
So you can introduce the natural log there in the beginning, but you have to come back to it.
Right, because our original thing is we want to know this limit. So I identify that and I say, okay, I'm going to give that a name. I'm going to call it y. And then I take the natural log, so then I determine the natural log, the limit of the natural log. So if I know what that's approaching, I know what y is approaching, and y has to approach e. Very first proof I saw in calculus in 1977 was this one. Did that make sense? Because Cole and all you other people, I said 1 also. That's what I wrote down. But it's not. And we didn't have, well, we had very primitive calculators. So it took us 20 minutes to come up with 2.718, whatever. But that's the process to get there. And it's limits that allow you to do that. So let's look at this one. What do you think? No idea? Well, if I have no idea, you know where I go to? I go home. No. If I have no idea, I go to the machine. What's the machine say? Somebody have a machine? Error? Okay, what are you inputting?
I'm tracing it now.
Okay, but what are you inputting?
I just put sine of x to x and I did the table graph.
I know, but what are you inputting on the table? You have to take a look where you're headed. What's this mean you're going to input?
So let's do from the right, like point three is zero.
Right, so you're going to start with like 0.3, 0.2, 0.1,
The answer's
0.0.
one.
So it says 1. Okay? So we know our answer needs to be 1. So we're going to start out the same way. We're going to say y equals the sine of x to the x. Now, what these look very different, but what do they have that's the same? Yeah, I have to the x power. And anytime I have to the x power and I want to find something about that x, I take a logarithm of both sides. So I'm going to take the natural log of both sides. And so what I'm going to do is take the limit of that. And I think you're okay with that now. That's another name for x. Now, as I approach 0 from the right of 1 over x, do you see that this goes to infinity? Because you're going to have 1 over 0.1, 1 over 0.001, 1 over 0.0001. Are you okay with that? Over here, I am approaching the natural log. So as I approach 0 from the left, excuse me, from the right, isn't sine going to 0? Correct? So where is the natural log going as you approach 0? So what would be the natural log of 0.1? What'd you get? It'd be negative infinity. What'd you get when you put the natural log of 0.1?
Oh, like negative something. Negative 2.303.
Okay, so then put the natural log of, so that means I can take the derivative, correct? So if I take the derivative, now what I have as x approaches positive infinity, what is this going to become? Yes?
Would you have to show that the top and the bottom result in infinity or negative infinity to then onto this point?
Yes, I would. Okay. I'm just trying to save us a little bit of time.
On the AP test, you should show that.
Right. You won't get a problem like this on an AP test. This is a problem that you would talk about in your second semester of calculus. Okay. So the derivative of this is going to be a negative 1 over x squared. Yes?
You said you had to show that the top and bottom like don't work, so the bottom would be the limit as x goes to 0, 1 over x.
Right.
And wouldn't that be like, you can't divide by 0?
Right.
So,
Isn't that positive infinity though? If I look at the graph of 1 over x, as I'm coming this way towards 0, doesn't it go up like that? What do I get here? What? Cotangent? Cosine over sine? So where is this headed? So I would examine this. You guys know what cotangent looks like? It's cosine over sine, correct? Right? And I'm approaching 0. What do I know about 0 in the denominator? You can't, correct? So there's got to be an asymptote at 0, correct? For cotangent. So as I approach 0, correct? Sine is getting really, really, really small. It's approaching 0, correct? So it possibly could be 0.1 because that's close to 0. It possibly be 0.2 because that's close to 0. And cosine is getting closer to 1, correct? So it's 1 over, isn't it this going to positive infinity? Because cosine over sine, this is getting extremely small, this is headed towards 1. So isn't that going to be positive infinity? What is this headed towards? Isn't that headed towards negative infinity? Okay, which means I can do what now? I can take the derivative again, can't I? So what's the derivative of this? How much time do I have in here? Okay, I was going to give you some time to work. Can I come back to this tomorrow? Is that all right? Okay, and I'll write something up a little bit nicer than all these scribbles. The biggest thing that I want you to understand, are you okay with this? How this became E? No?
There's just a lot going on.
Okay, can I recap that? Okay.
Yeah, I would not be
Watching you.
Well, you're going to be asked to do it on your own, so that's why I want to recap it.
Yeah, that's what we want to do. Yeah. I know it.
All right?
Uh-huh.
I think you're okay with that. So what I'm going to look at, so I take the natural log of y, and I get x times the natural log of 1 plus 1 over x. And so what I'm going to do is I'm going to find the limit as x goes to infinity of the natural log of y. I'm going to take the limit as x goes to infinity, and I'm going to write the natural log of 1 plus 1 over x over 1 over x. Okay? I'm going to write this as the limit as x goes to infinity of the natural log of x plus 1 over x divided by 1 over x. Using my log rules, I can say that's the natural log of x plus 1 minus the natural log of x over 1 over x. So now the limit as x goes to infinity is going to be 1 over x plus 1 minus 1 over x over 1 over x. Oops, that's wrong. And this is going to be the limit as x goes to infinity of x minus x plus 1 over x times x plus 1 divided by a negative 1 over x squared. That's the limit as x goes to infinity, a negative 1 over x times x plus 1 times x squared over negative 1, which equals 1. That means the limit as x goes to infinity of the natural log of y is equal to 1. That means the limit as x goes to infinity of y has to equal e, because e to the 1 equals y. And we'll come back to the trig one tomorrow. All right? Bye, Renee.